Honors Pre-Calculus Final Exam Review for 2013. This is number 41. Number 41 says find the missing parts of the triangle, and they give us a side, an angle, a side, and a side. And we have, again, no reason to believe that this is a right triangle. Since it's not necessarily a right triangle, we need to be thinking about law of sines and law of cosines. So let's start preparing this problem by writing out the given information. So we'll go ahead and prepare our given information where we have A, B, C. So we're going to write out what our solution for this triangle is going to be. And we'll have equals. So these are our sides and these are our angles. So we want to make sure, because it says to find the missing parts, there's going to be 6 parts altogether. So we're going to make sure we get the missing parts by just including the given parts. So they tell us that angle A is 44.29 degrees, and they tell us that side A is 51.82 yards, and we have side B is 63.64 yards. So let's look at the form of the information that we have, because that will help us decide what kind of triangle, what kind of rule that we're going to use. So maybe we could try drawing this triangle out a little bit. So I have one side, and I'm not sure the length of this side down here, but I do have an angle that is 44.29 degrees. So let's make that look sort of like a 45-degree angle. That's 44.29 degrees. And so if I mark that 44.29 degrees, then that must be angle A. Now my side A, that's 51.82, that must be over here. So let's put our side B. We can put it here or here. I'm going to put side B up here, 63.64. That's our side B. And that means that our side A, which is 51.82, comes down this way. And I don't know exactly what that looks like, but we can sort of approximate. I know it's less than this side, which is important to notice, 51.82 right there. All right, so that's what my triangle looks like. Now I can look at what the form of the given information is, because I have a side, and an angle. So when I see that, the first thing that I notice is I do not have side, 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 and I don't have side, angle, side. It would be side, angle, side if I had this angle. So it's not side, angle, side, it's not side, side, side. If I had side, 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 or side, angle, side, that's what would tell me that I would be using the law of cosines. But I don't have those things. So since I don't have those things, if not, I'm going to use law of sines, because what I have here is a side, and an angle. Well, let's look at how that's laid out, because I have an angle of 44.29 degrees, and that's angle A, and then I have side A, which is 51.82 degrees, and then I have side B, which is 63.64. I'm sorry, this is not degrees, this is meters or something. All right? So when I see that I have side, side, angle, right? We don't want to call it angle, side, side, but it's side, side, angle. Then when I have side, side, angle is when I want to be thinking about ambiguous case. So if I have side, side, angle, I want to be thinking I might have an ambiguous case if I have side, side, angle. If I have anything else, I don't have to worry about ambiguous case. But the first thing is if I have side, side, angle, it might be an ambiguous case. It might be no solution, there might be one solution, and there might be 2 solutions. And I need to figure out which of these things that it's going to be. And there are various ways to do that. But one thing that I do to start is I'm going to look at the side that matches the given angle. So I have one side that matches the given angle and one side that doesn't match. So we'll call this the odd side out, right? So in the ambiguous case, if the matching side is less than the odd side, the side that doesn't match, then we could have 0, 1, or 2 solutions. But if the matching side is more than the odd side, then we have one solution and that's it. So if we look at this, here's my matching side, it's 51.82, that matches my angle, and it's less than that other odd side. So what that means is I'm here. I could have 0, 1, or 2 solutions. And what that means in terms of the way I drew this, you can actually see what could be happening here. I drew the 51.82 going this way, but the 51.82 might go this way. And then I would have a different triangle, and we would still call this side A. It would still be 51.82, but I would have a different angle up here, I would have a different angle down here, and a different side length here. So there's a possibility here of having 0, 1, or 2 solutions. Now before I start doing the math, I don't know which is which. There are ways that you can do sort of a comparison inequality to find out ahead of time which is which. For myself, I like to just start doing the math. And if there's no solutions, you'll find out right away because you'll try to do a problem and there will be no solution to it. And if there's 2 solutions, we have an easy way to find that out, which we'll see in a little bit. So what I usually do is I start by saying, let's go ahead and set up this problem for a law of sines. We know it's a law of sines, so we can look at what are my given information. I've got angle A and side A and angle A, and I've got side B and I want angle B. So I'll start setting up my law of sines this way. I'll say A over sine A equals B over sine B. And then I'll plug in my given information. My A is 51.82. My sine of A is sine of 44.29 degrees equals my B is 63.64, and my sine of B I don't know, so I'm going to leave it. All right, so now we'll go ahead and solve that. Of course, you can cross multiply and solve this inequality. A nice shortcut is we'll multiply these two and then divide that one, and that will allow us to just say what sine B is. So sine B equals sine of 44.29 degrees times 63.64 divided by 51.82. And I can just go ahead and put that in my calculator just like that. So I will clear out what I have here. And we're going to do sine of 44.29 degrees. We got to make sure we're in degrees because this problem is in degrees. So I'm going to do sine of 44.29 degrees, and then I have to go times 63.64, so times 63.64, and then I'm going to go divided by 51.82, enter, and I get this, 0.8756. Now, for those of you who are good at looking ahead, the fact that you got a number less than 1 here already tells you that no solution is not an option. We must have a solution because this is something that could be the sign of a number. It's less than 1. So I'll write down what that is. It's sine of B equals 0.8576. And if you're not looking ahead, it doesn't matter. We'll just proceed and we'll find out soon enough if there's no solution or not. So now we'll do inverse sine of 0.8576, and that'll be what my angle B is. So now I'm going to go inverse sine, and I want to be as accurate as possible, so I'll keep all those digits. I'll just say inverse sine of my last answer, and I get 59.044. So let's just call that 59.04 degrees. Since their given information is in terms of 2 decimal places, we'll keep with that. We get 59.04 degrees. So now that's something we've calculated. We can put it on our answer list. We should go ahead and put that there right away, 59.04 degrees. You also, by the way, can get angle C right away. What I like to do is anytime I get 2 angles, I'm not going to do anything else. I'm just going to immediately find that third angle. So let's do that. We can do 180 minus parentheses 44.29 plus 59.04 close parentheses, and I get 76.67. So that's my angle C, 76.67 degrees. All right. Now, the fact that I got an answer, all right, if I had put this in and I got error, domain error, then I would know that there's no solution. There would be no solution. That would be 0 answers. But I did get an answer. I did get a solution. So that tells me it's not a no solution problem. So I know it's either 1 or 2. Now what I have to do is find out if there's a second angle or not. So the way that I go about doing that is what I'm going to do is go ahead and say, if there was a second angle, what would it be? If there was a second angle, we would call it B2, and that second angle would be 180 minus B. So in this case, that's equal to 180 minus 59.04 degrees, and that's equal to 180 minus 59.04. It equals 120.96. So it would be 120.96. So here's what I have. If there was a second angle, it would be 120.96. So now what I do is say, well, if that's the case, what would the C2 be? So we go ahead and calculate the C2. So C2 would be 180 minus A plus B2, right? So this is saying that this angle plus the angle A that was given add up with C2 to give 180. So in other words, in that third triangle, the angles will be A, B2, and C2. So the question is, can they add up to be 180? So what I would do is say, well, that's 180 minus my A, which is 44.29, plus my B2, which is what I just figured out, is 120.96. And here's the thing. If this turns out to be a positive angle, then yes, I have a second triangle. If this turns out to be a negative angle, well, a triangle can't have a negative angle, so there's not a second triangle. So basically what I'm doing is, once I find out what the B2 would be, I find out what the C2 would be to go with that B2. And if it turns out to make sense, because it's a positive angle, then I can proceed. If it doesn't make sense, then I'm going to leave that second solution out of the picture. All right, so now let's find out what that is. We have 180 minus 44.29 plus, so we have 180 minus 44.29 plus my 120.96. So 120.96, and that equals 14.75. And what I notice is that's positive. So it's a possible solution, 14.75 degrees. So now that I got a positive angle here, I know that in fact there are two solutions. So here's what I have to do back at my answer list. This is the first triangle, triangle 1. It's this outside triangle. It has an A1, a B1, a C1, an angle A1, angle B1, angle C1. I've already got most of that information. What I now know is that there is a second triangle. So the second triangle is A2, B2, C2, angle A2, angle B2, angle C2, and this is my triangle 2. Now, I already have a lot of information about that triangle 2. I haven't really finished triangle 1 because I have to get side 1. But now that we know that there's a triangle 2, let's fill in what we do know. First of all, anything that is given is common to both triangles. So if A1 is 51.2, A2 is 51.82. If B1 is 63.64, B2 is 63.64. If A1 is 44.29, A2 is 44.29. So all of the given information is the same. These are not givens, so I don't get to just copy them down. But I already figured them out. We already know that B2 is 120.96, 120.96. And we also know what C2, it's 14.75. 14.75 degrees. So now I've got everything in both triangles except for the C1 and the C2. So now I'm going to proceed to find the two missing sides in the two triangles by doing one more application of law of sines. So what we can do for C1 is we could do B over sine B equals C over sine C. The reason I don't want to do that is I computed B, and if I made a mistake, it'll make my side C wrong. So I'd rather use the given information. A over sine A equals C over sine C. So I can't avoid using sine C, but I can avoid using sine of B. So I'm going to start with finding C1. So I want to find C1. So I'm going to say A1 over sine A1. See, now since I have two of each, every time I refer to A or angle A or side B, I need to say whether I'm referring to 1 or 2. So I'm going to say that equals C1 over sine of C1. So now I can put in the information that I know. A1 is 51.82. Sine of A1 is sine of 44.29 degrees. C1 is what I'm trying to find out. I don't know what it is. And sine of C1 is sine of 76.67 degrees. So again, I can multiply the diagonals and divide the one that's left over. This time I'm not even going to write that out. I'm just going to say that C1 equals, and I'm going to go ahead and multiply and then divide. I might have to be a little careful with parentheses here, but I'm going to go ahead and do 51.82 times, I'm going to put this in parentheses just to be careful, sine of 76.67, and then I'm going to go divided by my sine of 44.29. So divided by sine of, I'll put that in parentheses as well. So we're going to put parentheses sine of, oops, there we go, 44.29, and close those parentheses, and we'll hit enter. And I get 72.21. So that's my side C1 is 72.21. So I have that side C1, and I can put that in here. I've calculated it. It's 72.21. All right, so now I've found side C1. Now I want to go about finding side C2 for my triangle 2. So I'm going to look at my given information for triangle 2. And in triangle 2, we can see that, again, I can use A and side A. This is given, and I'll use that with my C2 to find C2. So now I'm trying to find C2. I'm going to set it up very much the same way, in fact, exactly the way I'm setting up here, except everything's at 2. So we're going to do A2 over sine of A2 equals C2 over sine of C2. In fact, the A2 and sine of A2, since they were given, they're going to be exactly the same as what was over here. But I can write them from here. 51.82 over my sine of A2 is sine of 44.29 degrees. And that equals my C2 is what I'm trying to find out. So C2 is there. And then over sine of C2, I could have put in the value of 14.75 degrees. So we'll say sine of 14.75 degrees. Now, once again, I can multiply and then divide. And then I'll be able to directly say what C2 is by doing 51.82. So we're going to do 51.82 times sine, I guess I want to put that in parentheses, times sine of 14.75. And then we're going to divide by this one, which is sine of 44.29. Should put that in parentheses also. I might not have to, but just to be safe, 44.29. And then hit enter, and I get 18.89. So C2 is 18.89. And now I can put that in for my value of C2. It's 18.89. Now I have solved the triangle. I've done more than they said. They said find the missing parts of the triangle. But what they should have said is find the missing parts of the triangle. If more than one solution is possible, give all possible solutions. That's likely what the exam will say. So that's why we need to make sure, even though there's nothing in this direction that implied that there could be two triangles. We have to know that because it was side-side angle, that opens the possibility for the ambiguous case. Because the matching side was less than the odd side out, that left the possibility of 0 or 1 or 2 solutions. And then because when I went to find that third angle, it all worked out and nothing was a contradiction. I didn't get a negative angle. That means there were in fact 2 solutions and I had to give them both. Now the very last thing that I might want to do is just check to make sure these things make sense. If I have 63.64 here and 51.82, this is the triangle 1, the outside one. In that case, my C is going to, down here, should probably be longer than both of those, but not longer than the sum of them. So it's 76.67, it's a little bit longer than this one, and that makes sense with the way this triangle looks. And I can also look at what angle C1 is. So angle C1, since this is side C down here, this is angle C1, and angle C2 is this little angle. So if I have my angle C1 is sort of this large one, and we come up with 76.67 degrees, well, yeah, that looks like it's actually almost 90 degrees, so it is plausible. As long as I've drawn things somewhat proportional, it is plausible that that could be 67.67 degrees. And as for this side down here, well, my side C2 was 18.89. Well, this side here is short. It's rather short. So compared to 63 and 51, 18.89 is rather short, and that's what I would expect. And the angle is a very small one. This is a very small angle C2. So when I got 14.75 degrees for an angle, that satisfies my drawing that I should have a small angle there. So I find that my calculated information matches my drawing pretty well. Remember, you only want to be concerned about that if you can draw it fairly well. If your drawing is really rough, then you might just have confidence in your calculations and not be so concerned about the drawing. But that's how we're going to solve this. So it required us to use law of sines to check for the multiple solutions, and the very last thing we did was find C1 and C2 using law of sines, and we filled that information here and here. So that's number 41.